All right, this is A.REI.3 Algebra, Reasoning with Equations and Inequalities Standard 3, Video 9. Today we are solving absolute value equations. A few terms to know, please copy these down in your journals and define them. Absolute value is the distance a number is from zero on a number line. So we have a new symbol here. We have two lines that are going vertically up and down with a number on the inside. That symbol means absolute value. So if I were to say, what is the absolute value of 7? That is asking, what is the distance that 7 is from 0 on the number line? Well, 7, absolute value of 7 is equal to 7 spaces away from 0. If I were to say, what is the absolute value of -7, you would have the same answer, because if you're looking at a number line, -7 is also 7 spaces away from 0. Common error. The common error would be if you had a negative value on the inside, you would put the negative on the outside also. And again, that does not fall under the definition of absolute value. So all absolute value answers are positive numbers. Okay, this one we have a variable. Now we're missing the value of x. So it says, what value or values of x, when you take the absolute value of it, is equal to 5. Okay, so if you're thinking of any number inside of here that would kind of spit out this positive 5 answer, we just learned that you would be able to say that x could be both positive 5 and x could also be the negative 5. Because when you take the absolute value of them, you're going to get this positive 5 value. So x is equal to positive and negative 5. Solve the absolute value of some number x subtracted by 7 equaling 9. So can you think of that number in your head that when you subtract 7 from it and take the absolute value, you would get that positive 9? Okay, if you can't think of that number, or in this case there are going to be numbers, there's going to be two values for this. Take this equation, here's your quick trick. Take this equation, take the absolute value symbol off, so x subtracted by 7 is equal to 9, and try to get the other value of x by setting it equal to negative 9. So x subtracted by 7 is equal to negative 9. Because we know if we figured out the value of x when you subtract it by 7 to get the negative 9, when we get that value, we're going to be taking that absolute value of it to get negative 9, and then it will spit out that positive 9 answer. Let's see what I'm talking about here. Kind of confusing. So if I know that x subtracted by 7 is equal to 9, let's add 7 to both sides. So we're basically solving an equation for x. So x is equal to 16. So if I were to take my x being 16 right here, 16 subtracted by 7 is equal to 9. The absolute value of 9 is equal to positive 9. So there's one of your answers with the check. I'm checking my work. All right, the other side, when I took the absolute value braces off and set it equal to negative 9, let's see why we did that. So we add 7 to both sides. So x is equal to negative 2. So if I were to take the negative 2, let me erase this real quick. If I were to take the negative 2 and then subtract 7, negative 2 subtracted by 7 is negative 9, and then the absolute value of that negative 9, like we said, should be equal to positive 9. So your two values, as we checked above, x being negative 2 and the other value that would work is positive 16. So two answers. excuse me. Here we have a multi-step absolute value equation, and we're going to solve it like any other equation that has grouping symbols. So we're going to try to work our way to the inside of this grouping symbol by doing the inverse operations on the outside. So the first inverse operation I want to do is get rid of this -5 by adding 5 to both sides. And let's copy down all the stuff that we haven't used yet. And that's going to be equal to 4 plus 5 is 9. All right, working our way to the inside, we still have this 3 touching a grouping symbol, so that means multiplying. The inverse operation of multiplying is dividing. So let's get rid of that 3. So we have the absolute value of 2x minus 7 equaling 3. All right, we are right back to the screen previous to this. We need to come up with a value that when we multiply it by 2, we subtract it by 7, take its absolute value, it will equal a positive 3. And we're going to set that up in 2 equations. We'll take the brace off. 2x minus 7 equals 3, and 2x minus 7 is equal to -3. And let's go solve. Add 7 to both sides. We get 2x is equal to 10. So x should be equal to 5. And then on the right, add 7 to both sides. -3 plus 7 is 4. So 2x is equal to positive 4. So x is equal to 2. And you can go check those two answers and make sure that they work. You could even check them all the way up here in the original problem and make sure that the values of 2 and 5 both work for this equation. Okay, we have a special case when a no solution occurs. And it's important to note that the absolute value of a number is never negative. So looking at this first problem, I see that we have the absolute value of x equaling this -10 value, and this is not possible. That is a no solution. That can't happen. And then in the second problem, I see that I have my absolute value. I'm adding 8 to it, and it should be equal to a 6. So before I do any work with this absolute value, we must get rid of this positive 8 to be able to study what's going on with this x. So let's do our inverse operation. Subtract 8, both sides. The absolute value of x minus 4 is equal to 6 minus 8, which is a -2. And now that I've gotten rid of all of the stuff on the outside of these absolute value symbols, I can think about what's going on here. Is there any number that when I subtract 4 from it and take the absolute value, I could get a -2? And no, we said up here on the top and in our original screen at the beginning that the absolute value of a number can never be negative. So this is a no solution also. All right, then I have a common error. I call it a common error because, when you're taking a test or you're trying to get through some problems, you become very robotic in your thoughts and you're sometimes not thinking clearly as to what the problem is asking. In this case, you might be in a hurry and notice that we have an absolute value sign on the left and a -10 on the right, and you might just say, oh, wait a second, I learned in class, or I learned on this video that absolute value can't be a negative, so I'm just going to stop and call this a no solution. And you would actually be incorrect in this case, and let me show you why. Our rule is get rid of all of the stuff on the outside of the absolute value before we can even consider what the x plus 2 might be. So let's add 7 to both sides. Always follow our algebraic rules here. So negative 3 multiplied by the absolute value of x plus 2 is equal to, we have negative 3, because negative 10 plus 7 is negative 3. All right, I still have a negative on the right side. However, there's another step that I need to do to even consider what the x values might be on the inside. So let's do the inverse of multiplying by negative 3. We're going to divide both sides by that negative 3. And we have this absolute value of x plus 2 equaling 1. Now look at the right side. We have a positive value equal to an absolute value left side, and you're going to go ahead and try to figure out what those two values of x might be. So set up your two equations. Take the braces off. X plus 2 is equal to 1. X plus 2 is equal to negative 1. So x is equal to 1 minus 2, which is negative 1. And x is equal to negative 1 minus 2, which is negative 3. So we have answers of negative 3 and negative 1. Okay, go test those answers out. Okay, the last part is something called absolute deviation, and that is known as the absolute value of the difference of x and a given value. So we call it absolute error. Absolute error is equal to this absolute value, which I'm going to show you in kind of like a real world problem here. Next page. I'm a basketball coach, and before basketball games, the referee usually has an air pump, an air gauge, and tests the quantity of air inside of the basketball so that it bounces at the correct height during the game. You don't want a basketball that has too much air in it, and you don't want a basketball that doesn't have enough air in it. So we need to study that. We need to figure out what an acceptable amount of air could be on any given day. So for this particular basketball, it says that we have 8 pounds, pounds per square inch, that's PSI, with an absolute error of 1/2 PSI. So if I have an 8-pound basketball, I can have this error upwards or downwards 1/2 away from the desired amount. So if I were to set that up into an equation and I wanted the upside and downside of that 8 pounds, we could say that the absolute error can be 1/2 equal to the absolute value of some number x minus 8 pounds. And if we were to solve that, we would come up with both sides of the 8 pounds, take the braces off, like we've been doing, take the braces off, set it equal to 1/2, and set the second problem equal to negative 1/2. So x minus 8 is equal to 1/2, and x minus 8 is equal to negative 1/2, and you'll be able to figure out what would be acceptable on both sides. So, just think of it mathematically. If I am a half distance away from 8 on both sides, you'd end up with x being, let's just come up with the two values here. X would be at 7.5 and 8.5. Think of a number line. If you're standing on 8 and you go a half distance below it, you're going to end up at 7.5. And if you go a half distance above that, 8, you're going to be at 8.5. So that's what they're talking about when you're dealing with standard deviation. Okay, in your journal, I'd like you to define the given terms on page 2 of the flip chart and write a few sentences on anything new that you've learned from this video. And write down any questions that you might have, and let's bring those to class.